Okay, good morning everybody. I hope you survived the sample of Florida harsh winter that we had this morning, right? So we are going to finish up our overview of collection today with the topic of list range views. Okay, so this is the only view that we are going to cover, like I already mentioned a few times. So the way it works is mostly based on the method sublist. So you give two index to sublist. It works exactly as you would expect. So you call sublist on a list object, and it's going to return to you a list that contains all elements from index included, to index not included. So that the reason for that half open range is that this is pretty much what you would have here if you write a for loop, a good old-fashioned for loop with those two indexes, okay? So it's just to keep people in familiar setting there. So the advantage of that sublist, if it was just returning a copy, that would still be interesting, okay, obviously. But this one actually is right through to the original list, okay? So this is what's going to give actually range views their power. And we are going to see how exactly we can use that efficiently. So the big advantage that this slide tries to convey is that because we have those sublists that returns a view on an original list, we can pass sublist anywhere we are using list. Okay, that's the main ID. So that means that any of the standard operation defined on list are going to apply here. Any polymorphic algorithm that expects a list is going to be able to work with your sublist, okay? So you can start to see that sublists are kind of a way of filtering the content of your original list, right? You have a list of 50,000 individuals. You are going to take only like 10 of them at a specific range. So the range is your criteria, and the mechanism is pretty much filtering, okay? And you pass that to anything that would accept an entire list. So we can do some neat things with that. For example, removing a range of elements from a list. You can, let's say that the variable list is our main list, okay? So we call sublist on that. We specify two index from 5 to 10, for example. We get a sublist. That sublist is right through to the original list. So I clear my sublist. The clear method is meant to clear an entire collection, okay? You get a sublist and you call clear on it, you clear an entire collection, except that that collection happens to be a view which is a sublist of another list, okay? So you want to remove all elements from index 5 to index 15, there you go. You sublist your main list, and then you clear the resulting sublist, okay? And you're done. Searching for an element in a range, same thing, okay? This is the same ID here. So you have your list, you sublist it, and then you call any of the method of the list API. Okay, whether it's index of, last index of, or clear, doesn't matter. They do what they are supposed to do, and it transfers to your original list. Okay?
What is O?
What is O? An index, an object? Sorry, not an index, an object, yeah. Yeah, that's what you want to look for. Okay? Say that again?
Can you add a sublist, like additional element, and append some elements at the end of the sublist?
Okay, good question. Can we append actually at the end of a sublist? Yes, we can append. I have no doubt about that. The real question is, what is that going to do to the original list? Okay, I'm not sure it would write through append operations. If we add to the end, I'm not sure it's going to insert in the middle of the original list. Okay, would have to double check that. It's a good question. So, except appending, everything else I can guarantee is working. Appending, we'll have to check it. So let's try to use those idiom in a small code example, okay? So we are going to write a deal class. It's going to work from the command line. We call it. We say, I want to deal 4 hands of 5 cards, and it's going to give us the result of dealing 4 hands of 5 cards from a regular 52 cards deck. Okay, so each line here is a different hand, and you can count there are 5 cards for each of them. So we are just going to use that as an example of sublisting. Okay, So let's take a look at how this code is going to work. So we're going to start with a static method deal end. So we are assuming that we are passed a deck, okay, a list of element E that is a deck. We are passed the value n, and we are going to return a hand of n cards. Okay, so all of that modeled as list of element E. So the first thing we do, we get the deck size, no problem. Then we ask for a sublist, okay, and we are going to call that our hand view. So all we do here is we take the last n cards of our deck, okay, and we put that into our end view. Once we have this view, then we create an array list of elements from that view. So this is going to copy elements this time, okay? So once we are done copying the elements safely elsewhere, which is pretty much a hand is what we are going to return, right? So once we are done copying those elements elsewhere, then we clear the original view, which has as side effect to remove the element from our original list deck, okay? So we took the n last card of the deck, made a copy of them, made them disappear, and return that copy, okay? So let's put that into context with a class deal. So here's our main. So the main is going to handle the command line argument. Okay, so we make sure that you provided the right number of argument. There should be 2 numbers passed as a command line. So we make sure that args.length is appropriate. And then we start parsing those elements. So the first one is the number of hands that you want the program to distribute. The second is the number of cards you want for each hand. We just parse arg0 and args1 with integer.parseInt, and that's it. We have our integer value. Then we need to define some pretty much constants that we're going to use in the code. So we need like strings that represent all the suits, and we need strings that represent all the rank for the card. Okay, so we store that separately in two string arrays, suit and rank, respectively. And then we start creating our deck as an empty deck, as an empty array list of string. Okay, and the two nested lists that you can see, the two nested for loops, sorry, that you can see at the bottom are just there to say for each suit in my playing cards, I'm going to consider each rank, and I'm going to build a string that represent that specific card, and that's it. Once we have that, we take, so once we are done with that step, we have a deck, but the deck is ordered, right, by suit and by rank inside of every suit. So we are going to call collection.shuffle algorithm. So it's a static algorithm. It's one of those algorithms provided by the Java collection framework. We are going to shuffle that deck. Once we are done, we're going to check, and it's kind of a little late. We should have done that probably way sooner, but we're going to check that we have actually enough cards in our 52 card deck to accommodate the needs of the user, okay? And once we are done with that, then we start calling our deal hand method. How many times we call it? Well, number of times that you ask me to deal a hand of card. We pass our shuffled deck, and we pass as second parameter the number of cards that we need for each hand that we are going to generate, okay? And that's it. So it's just a very simple example. It illustrates, the most important thing it illustrates is that clear trick. Okay, that's something that we are going to probably use a lot. Other than that, it accepts as list. It shows that you can pass as list any sort of sublist. There's nothing really transcendental in all of that. Okay. A few things to watch out for. When you are manipulating that returned sublist that you get, okay? Like I told you, it's supposed to be right through to the original list, okay? Make sure that you do not, well, that answers your question, I guess, add or remove element from the backing list in any way when you are manipulating your return list, okay? So consider your view as something that is really built just for one operation. You need to do one thing. You need to clear element from index 5 to 10, create your view, clear, be done. Okay? Do not try to use the view in parallel with using the original backing list. Okay? That's going to cause problem. That being said, you can have a sublist of a sublist of a sublist of a sublist of a sublist and so on and so forth. No problem, except that you have to be very careful, okay? Because every time you create a new level like this, you have to keep in mind that rule do not modify the backing list, in parallel with modifying the sublist. So it's a nice feature, but it's a feature that has been designed to do one thing, do it quick, and be done with it, okay? So if you start building a bunch of sublists and you use all of them in parallel, it's going to be really hard, even by looking at the Java language specification and the API of the Java collection framework, to figure out if your code is going to be a source of problem or not. So that's code that's going to require a lot of testing, a lot of scrutiny, and then if something changes in the API implementation, if you were relying on one of those special side effects of that specific implementation, well, then you're done. You have to restart again, okay? So I would not advise to do that. My advice is use those sublists as transient object, as things that you can just create, use one time, throw away. Okay, it's probably safer to recreate several sublists in a fragment of code and use them once and then dispose of them immediately than to try to optimize, quote unquote, and end up in a situation where you have this kind of concurrent modification between the backing list or sublist and its related sublist. Okay, so just be careful with that feature. Next topic we are going to talk about, and this is something that we are going to go over again once we do streams. Okay, so we are going to look at the good old-fashioned way to do things with a basic Java API. Then we are going to get into a bit of things that are more specific to Java 8. Okay, so the concept of object ordering is simple. You want to be able to use the method collection.sort, so static method, one of those algorithms provided by the Java collection framework, okay? You want to be able to use that on your list, whatever implementation of list you are manipulating, okay? So that's one form of the method here, sort with only a single parameter, which is your list object. And if you have a list of basic things like date object, string object, things that come already from the Java library, well, they are going to behave already as you would expect. Okay, so the order that you have on a string is going to be the lexicographic order, on a date the chronological order, and so on and so forth. Okay, so we want to be able to manipulate that, but also with our own class like employee and stuff like that. So there are two ways to achieve this. There are two ways to make a class, objects of a given class, easily handled by the sort algorithm of the Java collection framework. One, you're probably already familiar with that one, implement the comparable interface. So once you implement the comparable interface in your class employee, then you provide that compare to method, pretty much. Once you provide that method, then you can pass an array list of employees to the collection.sort method, and it's going to know exactly what to do with it. No problem. Okay? If it just so happens that two objects are not comparable, there is a nice exception that is thrown by this algorithm. Question?
It could be implemented in a way that uses generics, yes, and will be compile time error instead. But here they chose the way to write it as a runtime. Okay,
that's a good point. The question is, you intercept at runtime a problem with the elements of your array list, for example, because you cannot compare two elements, but you should be able to detect that at compilation time using generics. Yes. That's your remark, right?
Yeah, so sort could be generic method. And
sort is actually a generic method. So I don't know what you would have to do to generate that class cast exception. I've never actually encountered that using the Java collection framework. It's still there. The documentation say if I stumble on elements I cannot compare, I'm going to raise that exception. But sort being generic, you are right. You would expect that this is actually locked down and cannot happen. So I don't know if this exception is there for some sort of legacy code compatibility, or if somebody use a row type and try to do something like that. Well, then there's still a way to catch it. Okay, but if you do clean generic programming, you're right, this should not happen, actually.
So IDE actually could help us at compile time. Because the sort is generic, it will show us that you provide, no, because it's list of comparable elements. It's kind of another level. So it will not
Plus, it's not really the ID. I mean, the ID is going to analyze your code too, but it's essentially the compiler that's going to tell you, if there is something that goes wrong pretty much with your usage of generics. Okay? So I'm guessing the extreme case that this is meant to catch is something like, we are trying to use row types. We fit them somehow as parameter of the sort method, and then only at runtime we realize that two things are not exactly what we expected them to be. Okay? Yep, question?
Can you have a list of a custom class?
Like employee, okay.
I made a class called entry, a generic class called entries, and I will create a list of entries. In that case, will this give me a compile time error considering I do not write my generic class saying my element extends comparable?
So if you have your own class, like for example entry or employee that you define, and this class does not implement the interface comparable, yes, you are going to have a problem. You are going to get, it's going to be detected at compilation time, okay? So that's the deal with collection. That's the whole point of this introduction to sorting, okay? Is you have two ways only to make your customized class acceptable by Java collection, okay? And as a matter of fact, there are a few things that are recommended that you do. Like if you are writing your own employee class and you want to put employee objects, inside collection, and you want to be able to sort the collection, you want to do everything that is available to do with a Java collection, you are like strongly encouraged to make it comparable. You are encouraged to implement also the equals method, okay, and make sure that they are consistent with one another. You are encouraged to implement toString. You are encouraged to implement the hash values, the method that returns the hash value. There is a whole list of things, and we are going to mention most of them in the lecture. There are a whole list of things that you need to actually implement that your objects should provide, even though not all of them are mandatory, strictly speaking, so that they interact nicely with the collection framework. Okay? So every time you are going to use collection, it's a free lunch, right? You're going to get a bunch of feature for free, except it's not entirely for free. You just have to be a little careful. Okay? The second method for us to make sure that our class employee, for example, is going to be sortable is to provide a comparator object. So that changed a little bit the way that we sort, obviously. When you call sort, you are going to pass your list, and you are going to pass also this comparator object. So it's a way to say, I want to sort things according to a certain criterion, okay? But that criterion should not be embedded in my class employee. So we're going to see an example of that. If you are trying to implement the comparable interface, you have to write one method in employee. Okay, so there is a strong coupling here between the comparator and your employee class. There is going to be also a strong coupling. Okay, in the sense that the comparator needs to know the detail of what field to compare, in your employee class. But you can have multiple comparators. That's going to be the main advantage that we see there. Okay. So let's take a look at our first approach, okay? And this should be mostly review, so we're going to go fast on it. It's the second one that is more interesting, actually. And actually, it's the second one also that is closer to what is done in Java 8 with lambdas. Yeah?
Actually, right, yes, IDE will mark, if you do not implement, comparables will mark sort, so you cannot call sort these objects that do not implement.
So what IDE are you using right now?
It's Eclipse.
Eclipse? Okay, so just for the record, Eclipse is confirming, when you're trying to, what do? You try to pass to the sort method an object of a class that doesn't implement comparable. Is that what you did? Yeah. Okay, so you get a warning by the IDE itself. But most of the checks that the IDE is capable of doing are, I would say, a subset of what the compiler is able to do. Except if you have installed some plugins that are actually doing static code analysis. So if you have some plugin that do static code analysis, sometimes this plugin is going to give you a heads up on something that the compiler might not be able to catch. Okay, static code analysis is very interesting. If you are programming in any serious way, you should really have this kind of tool available to you in your development environment. But that's just a side remark. So going back to object orderings, or objects ordering, sorry. So first method, we are going to implement the comparable interface. This is just a catalog that reminds you of all the classes. I think this is all of them, but all the classes that are actually implementing the comparable interface in the Java library. They all behave like you would expect, okay? The point here is not to surprise you. The point here is to provide to programmer, the feature that they would have otherwise to re-implement 99% of the time. So all of those classes are like ordered according to sign or unsigned numerical order. The Boolean false being lesser than the Boolean true is kind of an arbitrary decision. Be careful when you are dealing with strings. That's a topic we're not going to talk about in this class. But when you are dealing with string, yes, we use the lexicographic order, but there is such a thing also as a local, okay? So how many of you have ever heard about that? No, nobody? Local, yes, you heard about it?
Yeah, it's kind of cultural information. It's kind of
Yeah, it's kind of...
countries, languages, time zones.
Well, yeah, it's kind of a culture-bound information. That's a nice way to put it. It's actually the fact that in different alphabets you are going to have different orderings. Okay, even without considering human languages, if you are working on a bash shell or something like that, you can change your local. And even for the English language, you have a local where the letters are ordered in the order lowercase a b c d e f g blah 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 up to z. And then later on, uppercase A to uppercase Z. So if you are trying to sort something by lexicographic order in that locale, then you see that even a lowercase z comes before an uppercase A. But now you have alternative locales where you can have the lowercase a coming first, then the uppercase A later, then the lowercase b, uppercase b, and so on and so forth until z, okay? And the advantage of those local is that if you are trying to sort by lexicographic order, you are pretty much ignoring the case of the letter, okay? So we are just going to consider, the basic standard default lexicographic order that we have with a JVM without changing anything to the system configuration. But you have to be aware that if you are getting into stuff like that, if you are doing, for example, localization, internationalization of application, which is one of the things that IT professionals may end up doing, you are going to deal with that on a daily basis, okay? So let's take a quick example of writing our own comparable object. So we have a public class name, which implements the interface comparable of name. So we have two private final fields, first name and last name. So this is not even embodying a full employee. This is just embodying like the name part of a class employee, for example, or something like that. And we have a first name and last name accessors that they should have been called actually get first name, get last name to be consistent, but they just return to us the value of those private fields. Quick remark here, we have those strings marked as immutable, okay, marked as final in Java. This is actually a good idea. Every time you can do that, you should do that. And sometimes you have to do that. You're obligated to do that. Like if you are using your object, for example, as a key in a map, it's a good idea that if the key is based on the first name and the last name, for example, those fields are final. It's a very good idea to make those fields final, okay? Because think about it. You have a first name and last name. You use them actually to compute your hash value to insert in a map. You insert at a certain location in the map, and then you still have a dangling reference somewhere in your code to that first name, last name, and you modify the string, okay? String in Java are already immutable, the basic string, okay? String buffer is another story, but the basic string are already immutable. So in that case, that would not be the end of the word, okay? Except if you change actually those references here inside that object of class name. But the bottom line is, if you allow any way, any workaround to access the things that were used to compute your hash value and modify them after you inserted the object in the map table, you expose yourself to problems, okay? That would actually break the implementation. If this was allowed, that would break the implementation of the Java collection framework. So next step, we are going to have our constructor here. So the only thing we do that is, well, it's not even really out of the ordinary. The only thing we do that is additional to what the bare stuff example could be is this null checking here for the argument. So again, this is like a best practice. If you are going to insert something in Java collection, make sure that from the moment you call the constructor, your object is consistent. Okay? So in this case, in this example, we don't want to allow null first name, null last names. And it makes sense, okay? You need to have a first name, a last name. So we are going to enforce that from the very beginning. As soon as the object is created, it should be fully functional, ready to be inserted in a collection, compliant with the expectation of the collection, okay? Now, in another application, you might very well have some fields that are allowed to be null, okay? So this is just a policy here for the way we are going to use this name class. I mentioned that when you want to insert things in a collection, there are some methods that are really strongly recommended that you implement. Here are two of them. The first one, hashcode, is going to return the hash value associated to your object. Okay, so we're not going to go into hash function and stuff like that, so we use probably one of the most naive hash function here. Doesn't matter, it's a function of the hash code of the first name, the hash code of the last name, and then we multiply by 31 the first one just to get like something that is actually having some nice interesting properties, I guess. You have to redefine also equals. So equals is not here. Is it in the next slide? I don't know. You have to redefine equals to, and you have to make sure that if things are equal, they have the same hash code. Okay. So there is kind of like a trilogy of method here: equals, compare to, as we are going to implement it since we implement the interface comparable, and hash code. These are tied together. Okay, so when you introduce inconsistency between the three of those, you have to be really careful and you have to document it, because other programmer might expect that if compare to returns 0, then the object are also equals, then the object have also the same hash code. Okay, so these are kind of like the sensitive spots when you try to use really collection for your own customized class. And then toString, it's always a good idea to implement toString, even if it's just for debugging purpose. Okay, you want to see why your code is not working, you do a system.out.println of an object. Okay, well, it's going to look better on the screen, it's going to be more usable if you have some sort of implementation into string, okay? And when you are dealing with collection, the way that it works with collection also is that the Java collection framework toString method implementation for the collections relies on, expects that your individual objects have also a toString implementation. Okay, otherwise you get the default from object, which is really not that readable. Okay, so we talked about equals, so there we go. It's redefined also in this example. So we don't do anything like, again, really fancy or different here. The only thing I would put a remark on is that return false. That is just based on a test of the class of the object. So we make sure that we pass actually an object of the right type. Okay, and you can be as restrictive here as you want. And then we just use the first name and last name field to make comparison between the two strings. And two names are the same only if the first name and the last names are identical. And then finally, the compare to method. So the compare to method here is going to, the implementation is relatively straightforward, right? We are going to start by comparing the last name. So we store the result of that comparison in a variable last comp, okay? If last comp is different than 0, so 0 would mean that they are the same, okay? So if it's different than 0, then the result is last comp, okay? They are different, so the last name comes before the other last name, whatever. That's my result of comparison. I don't even look at the first name. Otherwise, then the result of my comparison is I compare now the first names, knowing that the last names are the same. And if there is an order to be found, then I'm going to return an order that is based on the first name this time. And because I rely on compare to, then if I need to, yes, I'm going to raise that class cast exception. So let's use this class in an example. So here's my class name sort. That's going to be my demo for this the series of methods. I have a main method here in which I define a name array, which is an array of object of class name. And I use the block initializer syntax with curly brace, and I create 4 of those objects in a row that I put in that array. Okay, so I have a regular Java array of 4 name objects. So I call arrays.askList to convert it into an array list. Okay, and then I call collection.sort on that array list, and then I display the names on the screen. And this is what I get. Okay, so works exactly as you would expect it to work. So we have a way to interact with the sort algorithm of the Java collection framework with our own custom classes and objects just by implementing the comparable interface. Now let's look at some of the limitations of this approach, and those limitations are going to be overcome by the use of a comparator. Okay, and then when we move on and we start dealing with Java 8 feature like streams and functional programming, pretty much what we are going to have is an easier way to handle comparators. Okay, so the limit case that we are going to consider here is twofold. Okay, one, let's say I want to sort an array list of dates, of date objects. Okay, but I don't want to use chronological order. I want to use something different. All right, so that's the first use case. The second use case is, what if I have a list of employees, but I want to be able to sort them by salary, and then I want to be able to sort them by age, and then I want to be able to sort them by, let's say, the names, okay, which I already implemented with my my previous example. So right now I have one way to sort in a class. And I can override the compare_to method, but I can override it only one time. So if I want to have different criterion for sorting, I can't. I cannot even change actually the signature of the compare_to method, because the compare_to method is not meant to receive an extra parameter that would tell me, for example, what kind of criterion I want to use to compare. So I'm stuck. So this is where comparator objects come into play. Okay, we separate the ordering concept from the implementation of the class employee, for example. So let's take a look. We're going to just use the same class employee that we've had all along. So we assume that we have whatever we need in it, social security number if we need it at some point, the hire date, the age, the salary, whatever. And then we have this class emp sort, which is going to illustrate how we can use comparators to sort an array list, for example, of employee object. So the first thing we define here is a static final seniority underscore order field that is actually a comparator of employee. Okay, so that field is going to represent our object of class comparator for the employee class. So we create here on the fly an instance, okay, and this is the notation for an anonymous inner class. So I'm saying I want to create a new instance of comparator of employee, and here's the curly brace, the opening curly brace. So let me give you the code for the actual anonymous inner class that is going to implement that comparator of employee. Okay, so the code is like it should be short. Okay, inner anonymous class should be always very short. We just implement one method. We implement the method compare that is defined in the interface of comparator. Okay, it takes 2 parameters, 2 objects of class employee, and then I can implement whatever comparison I see fit. All right, so this one, for example, is based on the hire date. So that makes sense. We call it seniority order. So we are going to compare the hire dates of 2 employees, and we are going to be able, with that sorting criterion, pretty much to sort our list of employees from newest recruit to oldest employee. Okay. So let's create now an employees which represent a database, a collection of employee. Actually, yes. Question.
So what if I wanted to compare first with the hire date and then with the social security number?
over the problem.
So we're going to cover that in a few slides, okay? The question is, what if I want to order according to two criteria? For example, I want to order according to the hire date, but then when two employees or more have the same hire date, I want to sort them inside that hiring date with, for example, the social security number. So we are going to do exactly that towards the end of that slideshow, okay? So employees, there are suspension dot here on how we create and populate here. Just assume that you are loading this from a file or something like that, and we are creating that collection of employee. Yeah, question?
Comparator is an interface.
What was the question? I missed that.
Is it class or is it an interface?
Comparator of employees and interface. All you need is to provide actually that method compare. Just like comparable of employee, what do you care about? You care about the compare to method, right?
I'm just getting confused because we're trying to create a new instance of interface and providing a body for that method.
Okay, so the question is, what's confusing in that example is that you just told me that comparator of employees and interface, but you tell me that you're creating a new object based on an interface, and we cannot do that. And then you're telling me you provide code for the interface. That's completely nuts, right? No, it's not nuts. You didn't lose your sanity. The way it works here is we do two things in a shot, okay? And this is a basic way that you use inner classes, okay? Anonymous inner class. It's always going to be that same template, okay? So in this case, our anonymous inner class is going to be defined on the fly. Okay? It is defined so that it implements the interface comparator of employee. Okay? So when I say new comparator of employee, I am not creating a new object of the interface comparator of employee. Okay? And if comparator of employee was a class and I could create object, I'm still not creating an object of that class. Okay? What I'm doing is two things. I'm defining a new class that doesn't have a name, and then I'm creating an object of that new class. Okay? So the way you read that is you say, I want to create a new object, and this object is going to be of this anonymous inner class. All of that, the yellow part and the comparator employee part as well. All right? And then the way that you further read this is you say, okay, this new class I'm trying to define implements comparator of employee. Or if comparator of employee was a class name, then extends that class. Okay? Where is my new class? Because you told me that it extends or implements, this class name here. Well, here it goes. This is a code for my new class. I didn't give it a name, it's anonymous, but here is my code. And my code, the only thing the code does is implement one of the methods. Actually implement the one method that the interface cares about. So that's a use case that you're going to see a lot, okay? You have an interface, you want to pass, you want to actually create an inner anonymous class that is implementing that interface. That's the notation you use. Then you create an object of that new inner class, you pass it to, or in this case we store it in a field, but we could pass it as parameter, do whatever we want with it, okay? And that's exactly, I would say that most of what you can do with Java 8 and the newfangled, functional features of Java, etc., most of it relies on that. It's just that, as you can probably all see, the notation to do that can be confusing, okay? Hence the question. So it's a lot of stuff here just to say, I want to pass a function. So the next thing we're going to do is we are going to actually do that. We're going to pass a function and stop worrying about anonymous inner classes that actually implement an interface, okay? And it's also confusing because the notation, the syntax itself, is kind of like off-putting because you're creating an object here, you are calling a constructor, right? This is what those parentheses mean. And this is what confuses most people the first time you see inner classes in Java, is that it's a call to a constructor, but you do not call actually the constructor of that thing here, comparator employee. In that example, that would not make sense, like you pointed out, okay? So it's a notation that is a call to a constructor, but really it's a class definition, but we don't see the keyword implement or extend anywhere. So, there might be some parsing reasons for which this is actually easier to parse by the compiler or even just unambiguous, okay? It's just that from the user perspective, the programmer perspective, yeah, it's a bit of a surprise there when you see that. Okay, so deal with it for now, and then we are going to simplify that, okay? So back to our employee database. I don't care really how it's built, from a file, from a socket, from anything, just hard coded in your program. Let's just assume that we have a collection of employee, okay? Employee objects. And then here's our main method. The main method is going to take that collection of employees, convert it to an array list of employee. We're going to call that E, and then we sort E by seniority order. So we pass just the comparator object here that has been created from that anonymous inner class, okay? And we get the sorting that we want based on the criterion that is implemented right here, okay? So let's take another look at this solution, and let's try to poke holes into it, see what could actually be a problem. The main issue here is that the way that we wrote it, okay, we have this gap between equals and compare, okay? The same kind of gaps that we discussed a few lectures ago when we talked about, okay, make sure that if you implement compare to, the compare to method from the comparable interface, you also keep equals consistent, okay? So in our case, we don't have that consistency. So even for an example as easy, as obvious as this, you can see that some problem can creep up very easily, okay? So here's a way that you can fix that, hopefully. So we have still the implementation here of a comparator object that we are going to use as seniority order. Okay. The only difference is that we start by comparing the higher dates. Okay. We store the result of that comparison like we did a few slides ago. If the result of the comparison is different than 0, then that's it. We can tell the two employees apart based on their date. That's fine. And then, if it is actually 0, this is when we add a little bit of code. Because if it is 0, right, this is when equals is going to return true. So the problem we had is we can have two employees that have the same hiring date, but that does not mean that they should be considered equals. They can have, and they should have, most of the time, different names. They will have different social security number and stuff like that. So what we are doing here is we are adding another layer that says, okay, I can tell apart employees by the hiring date and I can sort them based on that. Check. But now, in the odd case where they have the same hiring date, I want to return something more to allow to differentiate employees that actually have the same hiring date but a different name, for example. So in this case, I use the employee number, which is assumed to be a unique ID, okay? And I pretty much use that as a way to differentiate the two employees, and that's it, okay? So again, it's when we start looking into ways to do that, by passing functions, there are going to be easier way to handle multiple level comparison. Okay, where you can say, for example, and that goes toward the question that you had at the beginning, when you want to say things like, okay, I want to sort my employees by age, okay, and then within an age group, I want to sort them by first name, last name. All right. So if we want to do that here, it's still a bit of a pain. Okay, it's a big pain actually because we have to implement everything in one comparator. Once we are able to pass easily functions to act as comparators, we are going to have like an API that allows us to say, hey, I want you to sort with this comparator, and inside results that have the same order with that comparator, I want you to use the second comparator.
So,
yes?
why did you do E2 dot compare to E1? Why did you went with the E1 dot compare to E2?
Okay, I missed that.
Okay. Why are you doing E2 dot compare to E1?
E2 dot compare to
date compared to E1, like while comparing E2 to E1, why not E1 dot compare to E2?
Okay, so the question is, why are we comparing E2 dot higher date to E1 dot higher date? Because that's the order you want to implement. If you want the opposite order, then you would compare E1 dot higher date to E2 dot higher date.
Okay.
Which one comes first, okay? Compare to is going to tell you the object on which you applied me, you called me, comes first. Well, if you put e2.hiredate, first, that's the one that, comes first. Does that make sense?
Yeah.
Okay. All right.
There will be difference in results for both of the cases. Like if you put E1 first and E2 later, there will be difference in result there.
Yeah. Yeah. There would be difference in the outcome of the compare to method depending on which object you pass first. So by pass first, I mean which object actually you call the compare to method on and which one you pass as parameter. Okay. Remember that compare to returns free value, okay, and compare works the same way. The idea is you return negative if the first, is the object on which you call the method comes first. You return 0 if they are the same. You return positive if the object you pass as parameter comes first, okay? So, yeah, if you switch the order of the object, you're going to get different results, except if both of them are the same. Then, yeah, you get the same, then it doesn't matter, okay? All right, we're almost done with Java collection. So this is going to be just a few slides, and it's just for you to have as reference, actually. So I'm going to go relatively quick because there's not much material in there. So this is just to give you an overview of the available features from the algorithmic perspective, okay? The algorithms that are implemented in the Java collection framework already for you. So we know already what to expect, okay? We have used sort, we have used shuffle, we have used this kind of algorithm, okay? So the same way that an array list is there to give you a reusable data structure, when you use one of those static methods implemented in the collection class, you are going to get access to algorithms that are meant to be reusable across method. Okay, so data structure. So most of them are going to work as is on the list class. No surprise there. Some of them are going to be actually able to handle different types of collection. Okay, so we are going to look at quickly 2 different lists. So this is a part I told you that was more of a reference for you to have during the exam. Okay, it's not something that we're going to go over and talk for like hours. 1, 2, 3, 4, 5 different algorithms that work on list. So we already talked about sort. We already used shuffle. You have also reverse. So all of those are self-explanatory, okay? If you have a question about any of those, interrupt, okay? But I'm assuming it's pretty clear. We've also seen swap, which allows you to consider 2 elements in a list, for example, and swap them around. Rotate is the one that we haven't yet illustrated in any example. So it's going to allow you to rotate the element in a sequence. So that means that the last one becomes the first one, for example, if you push by 1, and you consider that you have like a circular list, okay? So again, basic traditional operation that you could expect on any sort of list. Then we talked about, I think we talked about replace all, probably just briefly. So it does exactly what you would expect. Replace all instances of a given element by the new value. Fill is good for initializing those kind of list collections. So you specify, I want a collection of 50 million copies of the same string. So that's going to be a little easier than to try to initialize it with a block notation. Copy, again, self-explanatory. Binary search, you are going to hear some people use the term dichotomic search. It's exactly the same thing, okay? A binary search is an efficient search algorithm that allows you to detect if an element is present in a list or not, okay? What else about it? Well, that's pretty much it. Yes, the only thing you have to be careful about is if you want to use a binary search, you need your list to be already sorted, okay? But if any of you took data structure, you probably implemented by hand a binary search, you probably already played with all that stuff. If you have questions, just come during office hour and we'll patch you up on whatever you missed, okay? Index of sublist and last index of sublist. These are interesting, actually. What you're going to be able to do with index of sublist is you are going to pass 2 parameters, okay? So your first parameter is actually the list in which you want to find the sublist, I think. Yes. So that's your list of, for example, 50,000 employees. And then your second parameter is a sublist. So what this is going to tell you is, okay, I found your sublist in the original list, and it starts at index 5. And of course, the difference between index of sublist and last index of sublist is that if the sublist occurs several times in the original list, well, you want the start of the first occurrence or the start of the last occurrence, okay? And then we have just a few methods that are going to work regardless of your collection. So not only list, pretty much. So add all, we already used that one, we already saw that one. Frequency does exactly what you expect. It's going to tell you how many times a given element occurs in a list. Disjoint is going to test whether two collections are the same, contains the exact same element or not. Min and max, again, self-explanatory, finds the smallest or the largest element. So for those, you need a criteria, right? You need something to compare. So again, when we do functional programming, we are going to be able to pass easily functions that say, I want to find the mean according to the age of an employee, or I want to find the mean according to the social security number of an employee, or whatever you can think of, okay? Just a closing remark on the sort algorithm that is implemented. Well, obviously, it's a good algorithm that's implemented by default in the Java collection framework, so you should never have to worry about re-implementing your own sorting algorithm, except if your sorting problem has some very, very specific characteristic, okay? Again, if you took a data structure class and you studied sorting algorithm, you know that there are things like, for example, sorting in place or sorting not in place. And sorting in place means that you can have access to the entire collection memory in RAM, and you can do your sorting like this. And then sorting not in place means that you have, for example, terabytes and terabytes of data on disk. These form a collection. You want to sort that collection, but there is no way to load it all in one shot, in memory. Well, that would be an example where you need to do something different, okay? But for 90%, I would say, or 99, I don't know, whatever huge percentage of application, you are going to be able to just rely on this default sort implementation, which is actually quite efficient. One quick remark that is actually amusing. It's actually not a quick sort that is implemented in the Java collection framework. It's a merge sort algorithm. They are pretty similar in terms of performance. It's just that this one empirically showed improvement over the quick sort, okay, on most use cases. So it's not a matter of complexity being tremendously different. It's just a matter of empirical performance. And then the last thing is, besides being fast, this algorithm is also stable. So we already talked about what it means for an algorithm, a sorting algorithm, to be stable. That just means that if you have a list, and this goes again toward your question sooner, if you have a list that is already ordered by alphabetical order, okay, and then you tell me I want to sort that list by salary. Well, inside each salary group, okay, so everybody will earn the same salary, you are going to have for free the lexicographic order on the names preserved for you. That's it, okay? So that means that a stable sorting algorithm is not going to swap around element if it doesn't have to, okay? If two elements have the same salary, they are not going to be, their initial order in the original list is not going to be modified when we try to sort them by alphabetical order, for example, okay? All right, last two slides, sorting based on comparables. These slides are not really useful. We already saw that. And there is actually an interesting example of anagrams in the Oracle tutorial. So I invite you to look at it if you're curious. It's going to use hash tables and stuff like that as well. So this is, the only reason I'm mentioning it is that this is actually extracted from that example. But the only thing we care about in the context of this specific lecture is this implementation here. And this is totally similar to what we have done before. So like I said, those two last slides, I'll probably remove them in a future version of the course. There are two examples, but we've seen already examples of implementing comparable and implementing our comparator. So they're kind of redundant. Okay, and this wraps it up for actually our overview of the Java collection framework. So hold on, I'm going to take question in a second. I'm just going to start the uploading while I switch slideshow, okay? So